So for the bottom-up approach for coin change, we'll initialize a grid, call it DP, and we'll have it with coins.size, number of rows, and for the columns, we will have amount plus 1 elements in the columns. Because, for instance, if we have the amount is 3, then we want to populate, then the first column, so the 0th column, will have an amount of 0, so we'll consider amount of 0 in the 0th column, amount of 1 in the 1th column, and so on. And then in the 3rd column, we'll consider amount of 3. So 0, 1, 2, 3, that's 4 elements, so that's why we have an amount plus 1. And then we initialize all these to amount plus 1. You can initialize it to inmax as well. I guess I'll just initialize it to intmax for consistency with my previous video. See part 1 if you haven't already. I think approaching DP problems top down probably gives you a better intuitive sense of the problem instead of just approaching the bottom up solution directly. And then we'll just initialize the first 0th column, I guess, to all zeros, because for the amount 0 there is only the 0 combination, like no coins. If you have 0 coins in the knapsack, then it'll just work. Yeah. Okay. So we'll just have I is less than coins size plus I, and then dp of I 0 is equal to 0. And now we get to the meat of the knapsack algorithm. I'll just have the outer for loop iterate through the different types of coins, and I'll have inner for loop iterate through the different amounts that we want to consider. We can skip the 0th amount because we already put the logic there on lines 9 and 10. So j is less than or equal to amount, because we want to go through the entire column. And there are amount number of elements inside of that column. Wait. Inside the row, sorry. Yeah, okay. And we'll initialize in incurval. Actually, I'll just first initialize the xcurval to be equal to int max, and I'll initialize incurval to also be int max. And I'll have an if statement. If I is greater than 0, then we will initialize xcurval to be equal to dp of I minus 1 j. So dp of I minus 1 j is just the number of coins, the fewest number of coins if you don't consider the current coin. So if you don't consider the ith coin. You have this condition right here just because you don't want there to be a negative index. And to initialize incurval, we'll have the following if statement. So if j is greater than or equal to coins I, then we do the following. Incurval is equal to dp of I j minus coins I plus 1. So dp of I j minus coins I is just the fewest number of coins for the amount, for the current amount minus the value of the coin. So because you're including the current coin, ith coin, you just do a plus 1. So now to like initialize the dpij, we just take the minimum of the x curve val and the in curve val, because you want to find the fewest number of coins that can make up this amount. So after this, then we will initialize an if statement. I mean, we'll write out an if statement, initialize an if statement. Okay. So if dp of coins dot size minus 1 amount is equal to int max, then we will return -1. So dp coins dot size minus 1 amount, that's the last value that we compute. So it's the number of coins if we consider all the different all the combinations, and for the largest amount. So then we return this thing, if it's not equal to int max. And that should work for the cases right here that were given. So like I'll just run it to show you guys. Oh wait. Error. Use of undeclared identifier coin. Give me coins. Yes, I did. So I'll go to line 5. Yes. And then hopefully it works. The last 2 times I recorded, this didn't work. Okay. Overflow. I guess I'll just change this to be equal to amount plus 1. Either way works, because with amount plus 1, like there can't be amount plus 1 coins inside the knapsack, right? Because the smallest coin value according to the problem is 1. So amount plus 1. Oh my gosh, okay. Please, please, please. Okay, yeah, that works. And then I'm just gonna test out this as well. You guys could go ahead and skip this. Oh wait. Okay. Yeah, if you guys want to, you guys could skip this part. I'm not giving out any insightful information here. Yeah, so this works for the given test cases, but it doesn't work for like the overall thing. Like if you have very large values inside the coins, then it doesn't work. So we need to optimize this further. And that's it. I will try to make the entire solution visible. Wow, that was very sudden. Okay, there you go. That's the entire solution if you want to see it more clearly. Well, thanks for watching. I'll try to make better videos in the future. Yeah, so next up, we'll just try to optimize this solution so that actually works. Okay, for the LeetCode problem. Thanks.